Today we're diving deep into the fiery heart of our planet to explore a topic that is both fascinating and a little bit explosive. We're talking about volcanoes, specifically what happens before they erupt, when the pressure starts building up inside a magma chamber. It's like a giant geological pressure cooker, and understanding these signs is crucial for science and safety. So buckle up, because we're about to explore the incredible science behind a volcano's awakening. When we talk about a volcano getting ready to erupt, one of the most critical indicators scientists look for is an increase in pressure within its magma chamber. Imagine a gigantic underground reservoir filled with molten rock, superheated gases, and crystals. That's your magma chamber. It's not just a static pool. It's a dynamic system. When new magma from deeper within the earth pushes its way in, or when gases dissolved within the existing magma start to exsolve or separate out due to changes in pressure or temperature, the volume inside that chamber expands. And just like blowing air into a balloon, that expansion means increasing pressure. This pressure isn't just theoretical, it manifests in ways scientists can actually measure. One of the primary methods is called ground deformation. Think about it. If something huge is pushing up from beneath the surface, the ground above it is going to move, right? Volcanoes often breathe, they inflate and deflate. Before an eruption, this inflation can be significant. Scientists use incredibly precise instruments like GPS receivers placed around the volcano, and even radar imagery from satellites orbiting Earth to detect even tiny changes in ground elevation or horizontal movement. We're talking millimeters or centimeters, but over time, these subtle shifts can paint a clear picture of what's happening underground. It's like watching the belly of a sleeping giant slowly expand. Another telltale sign of increasing magma chamber pressure is seismic activity. Earthquakes are a common occurrence around volcanoes, and their patterns can tell us a lot. As magma moves upwards and forces its way through existing rock fractures or creates new ones, it generates small earthquakes. These are often called volcano-tectonic earthquakes. They might be very shallow, indicating magma moving close to the surface, or deeper, suggesting magma moving from the mantle into the chamber. Sometimes we see long-period earthquakes, which are caused by fluids like magma or gas resonating within cracks and conduits. It's like the volcano is groaning or rumbling as the pressure builds, and seismometers are its ears, listening to every sound. Changes in gas emissions are also a huge clue. Magma contains dissolved gases, just like a soda bottle. As magma rises and the pressure decreases, these gases, primarily water vapor, carbon dioxide, and sulfur dioxide, start to come out of solution. If the magma chamber pressure is increasing because more gas is exsolving or new gassy magma is arriving, scientists will often detect an increase in the volume or composition of gases escaping from fumaroles, those little vents that often dot the flanks of volcanoes. Tracking these changes with gas sensors on the ground, or even from drones and satellites, can provide crucial real-time data about the magma ascent and the pressure dynamics below. An increase in sulfur dioxide, for example, often indicates that fresh, gas-rich magma is getting closer to the surface. So, how do all these pieces fit together? Imagine a team of volcanologists monitoring a potentially active volcano. They're constantly analyzing data from ground deformation sensors, looking for inflation. They're sifting through seismic records, mapping earthquake locations and magnitudes. They're flying drones with gas sensors to sniff out changes in volcanic plumes. Each piece of data, whether it's a subtle ground bulge, a cluster of small earthquakes, or an uptick in sulfur dioxide, is a puzzle piece. When multiple pieces start to point in the same direction, specifically towards sustained ground uplift, an increase in shallow seismicity, and changing gas chemistry, that's when the alarm bells really start to ring. It suggests that the magma chamber is not just pressurized, but that the magma is actively migrating upwards, making the volcano eruption ready. It's important to remember that not every increase in magma chamber pressure leads to a spectacular eruption. Sometimes, the pressure might build, cause some ground deformation and earthquakes, and then fizzle out. The magma might stall, cool, and solidify underground, or the gases might escape without a full-blown eruption. Volcanoes are complex systems. and predicting their behavior is one of the toughest challenges in earth science. But by diligently monitoring these key indicators, scientists are constantly refining their understanding and improving their ability to forecast eruptions, which ultimately saves lives and protects communities. The work of volcanologists is truly incredible. They are on the front lines, deciphering the subtle messages the Earth sends us from its molten depths. Their dedication to understanding these powerful natural phenomena helps us coexist more safely with our planet's dynamic forces. It's a constant dance between observation, data analysis, and scientific interpretation. Thank you so much for joining me on this deep dive into magma chamber pressure. I hope you found this exploration as fascinating as I did. If you enjoyed learning about the science behind volcanic activity, please give this video a thumbs up, share it with your friends, and don't forget to subscribe to the channel for more exciting science content. Your support helps us keep exploring the wonders of our world. Stay curious, and I'll see you in the next video.